Okay, congruency of overlapping triangles. We're going to go over this. Highly doubt that I will test on it. It's kind of I want you guys to see this. I'm going to be when we do a test on this. I am going to be looking really hard at the side angle side, side, angle side, those type of things. Yes. No. No, I'm not gonna test you on proofs because we really haven't worked a lot on proofs, and I haven't worked with you guys on proofs, so don't expect something like that. All right, but we are going to go through this, and we're going to go through a proof because I want you to understand how they know that these two overlapping triangles are congruent. All right, and it's important to see this. What they're given here is that they say that these two overlapping things were given that AB, this line right here, and BC, these two are equal. They're congruent. All right? They're given that AE and CD are congruent. They're given that the angles AED and CDE are congruent. Okay? So right there, we should be able to look at it and say, well, can we talk about any angle or side angle side at this time? But is that a congruency? AS is not a congruency. All right. Angle side is not a congruency. All right. That's all right. That's why I tell you that. It's one to remember. It's one that you obviously will remember, and it's not a congruency. Because your sides, if you were going to do, let's say a side, and then you had an angle here, right? Well, this side could be going out this way, right? Or it can be coming back in this way. It won't work. You won't ever have it where you'd have a consistent third side. Okay, so we look at this. We got a side, and we got an angle. We really don't have anything that we can say that they're congruent at this point. So we have to prove that triangle ABE is congruent to CDE. Okay? CDB and AEB. Let's go down. Am I like the coolest teacher in the world? Yeah. Oh. Okay. We're going to redraw these triangles, and that's what they ask you to do. They ask you to redraw the triangles the way they had them up here, but it's two separate triangles. We got our given stuff here. All right. We got our given stuff here, and we have our proof. So we write down our given information. All right, we write our given information in here as to what was given. And then we start. Well, we know when we look at these that ED and ED, they're the same, right? So they have to be congruent. We can say that this side here is congruent to this side here. That's a reflective property. As soon as we do that, look what happens. We have a side. We have a side and a side. We got an angle and we got a side. Side, angle, side, angle, side, which is, sass on your part, yes, is congruency. All right? So right away we can turn around and we can say, well, that AED and CDE are congruent. We know that these big triangles are congruent. Remember, we're trying to prove these smaller triangles. We've just proved that the bigger triangles are congruent. Okay? Next, angle A then is congruent to angle C. Angle A and C are congruent. Why? They're perfect. Because the triangles are congruent. Since these big triangles are congruent, then these angles must be congruent, right? whatever the heck that stands for. Then side AB must be congruent to side CD, correct? It would have to be. That was the given. So then, through side, angle, side, or side, remember that this side here is congruent to this side here, right? Side, angle, side, or this way, side, angle, side. We have congruency of the triangles. All right, it's using what you're given to be able to figure out one part of it that's going to help you figure out the second part of it. Yeah. Congruent parts of a triangle or something. Google it. Now, don't worry about it here. It says separate and redraw overlapping triangles. Identify the vertices. Okay, angle, triangle GLJ. GLJ. So this, hate it when you do that. This triangle right here and this triangle right here. All right? And we know that angle K. What do we know, first off, when we first take a look at this, what can we say about vertical angles? They're congruent, aren't they? We can talk about K is congruent to this one here, this one's congruent to that one. That's something we know. We know that diagonals of a polygon bisect each other, right? Or quadrilateral, they bisect each other, so that this side equals this side and this side here equals this side here. We can identify how to prove that if we needed to. We have enough stuff to do it. How about this one here? MRP, this triangle here, and this triangle here, NSQ. Well, where would we start in this? Well, we don't know there's 90 degrees in there, right? And it's really saying identify the vertices. What would be the vertices? My vertices here would be NSQ, which is pretty simplistic, I think. But we could turn around and we could say that these are vertical angles. We could probably end up proving that these triangles here are congruent. We could probably end up proving that these triangles here are congruent. And we could probably, since these are congruent, then this side equals this side, and this side equals this side, so that these here equal these here, this length, and that these lengths equal these lengths. There you go. Corresponding parts of congruent triangles are congruent. I know. I believe it. I believe it. All right. Yes, it is. All right. Is there a proof? Do we have to? No. I want you guys to know this. I wanted to show you this